Good morning, everyone. Very good morning. Shall we begin the session? Today's topic is UML, Unified Modeling Language. In the last class, we have finished with the various alternatives for the ER models. What are the various possible outcomes that is available with the ER model, or what are the various alternatives that is used in place of the ER models or ER notations. And the next part is a UML, Unified Modeling Language, that helps to model the data representation, and that is very easy to use for a software component. That also forms one part of the overall software design. In simple terms, UML is Unified Modeling Language. That is a language in which we use the diagrams to express each and everything, to express the languages, to express the standard, to express the OMG for the, that is object management group. All right. So just wait for 5 minutes more. So now shall we begin the session? Okay, let's start with the UML. Larry, why are you so late? Okay, so entity relationship diagram, that is the ER model, helps a representation component of a software system. So whenever we are taking out the user interaction, whenever I want that the diagrams interact with each other, that is required by the system design. Other components includes model of the user interaction along with the system, specification of the module or function module of the system and their interaction. That is how user interact with the module, how the various components interact with the module, what are the various specification of the functional module. So that is done by that is defined by the UML, that is a unified modeling language. So this is the standard developed under the developed under the aspects of the OMG, Object Management Group, for creating the specifications for various components of a software system. For example, if I'm talking about the analysis design, each and every part, that is also represented, that is also explained with the help of the UML. So some of the parts of UML are class diagram. So a class diagram is similar to a ER diagram, and in this section we illustrate a few features of the class diagrams and how they relate to ER diagram. That is how they related with each other, how they communicate with each other. That is a class diagram. The next one is a use case diagram that also represents what are the various data that is representing with the class diagram. That is defined by the class diagram. So whenever we represent the diagram, that is representing within the features of the ER diagram, how they related with each other, how they interact with each other, communicate with each other. The next one is a use case diagrams that also shows the interaction between the users and the system, how users interact with the system. ER diagram shows how entities relate with each other. Use case diagram shows how the user interact with each other, or how the user and the system interact with each other, and in particular the steps of tasks that user perform, such as withdrawing money or registering for a course. The next one is activity diagram that represents the flow of tasks. So to see the difference between these diagrams, class diagram between entities, use case diagram between the user and the system, activity, how the activity will be done, that's the flow of the task between various components of a system. Then implementation diagram, how the system will implement at the user's end at the user scenario. So implementation diagram shows the system components and their interconnections, both at the software component level and the hardware component level. So we do not attempt to provide detailed coverage of the different parts of UML over here. That is used with some features of these or that part of UML that relates to the data modeling through examples. Now, this is a figure that illustrates or that shows the comparison between the ER diagrams and the UMLs. So we describe these constructs over here. So UML actually models the objects, whereas ER models the entities. So one is objects, one is the entity. Objects are like entities and have attributes, but additionally provides a set of the functions known as the method that can be invoked to compute values on the basis of attributes of the objects. What are the various attributes? What are the various objects that is represented, that is used to update the object itself? And these class diagrams can also depict the method in addition to the attributes. And UML does not support composite or the multi-valued attributes and derived attributes that are equivalent to the methods, that takes no parameter, that takes no usefulness. And since classes supports encapsulation, so UML also allows the attributes and the method to be prefixed with plus sign, minus sign, or the hash sign, which denotes respectively public, private, and protected access. And these attributes can only be used in method of the class, that is the private attributes. And protected can be used only in the methods of the class and in its subclasses. So these should be familiar to anyone who knows Java, C++, or C#. And when we talk about the UML terminology, relationship sets are also referred as the associations that are also referred as the relationship sets for consistency and the ER terminology. So we represent the binary relationship set in UML by just drawing a line, by just connecting with the entity sets, by connecting with the relationship set that is adjacent to the line. And we may also specify the role played by an entity set in a relationship set by writing the role name on the line with the entity sets. And alternatively, we may write the relationship set name in the box along with the attributes of the relationship set and how they connect with each other. This is the ER diagram notation. This is the equivalent in UML. This is the entity with attribute, simple, composite, multi-value derived. Class with the simple attributes and the method, attributes, prefixes, public, protected, public, private, and protected. So these are the attributes that may includes simple, composite, multi-value derived. This attribute denotes public, private, and protected. Then E1 R E2, role 1, role 2, binary relationship. Role 1, role 2, E1 E2. E1 E2 A1, E1 E2 R1 A1, role 1, role 2. So these are the relationship between the ER diagrams and the equivalent UML diagrams. The next part is E1, E2, then 0 to many, 0, 1, 0, 1, or 0 or 1 to many or 1 to 1 relationship. Then N to array or N array relationship attributes, cardinality attributes, then overlapping generalization, overlapping. So this is E1, E2, and E3. So these are the various symbols that is denoted in the ER diagrams or UML diagram that also represent the disjoint, that also represent the relationship between the attributes. Now these are represented with a dotted line to the line depicting the relationship set. And this box can then treated as an entity set in the same way as an aggregation in an ER model. It can also participate in a relationship with other entity sets. And UML also supports non-binary relationship using the same diamond notation, diamond box, that is used in the ER diagram. And non-binary relationship should not be or could not be directly represented in the earlier versions of UML. They had to be converted into the binary relationship by the techniques but it is used that also allows a diamond notation to be used even for the binary relationship. And that constraints are specified in UML in the same way as it is defined in the ER diagrams, where L denotes the minimum, H denotes the maximum number of relationship as an entity that participates. However, you should be aware that the positioning of the constraints is exactly the reverse of the positioning of the constraints in the ER diagram. This is 0 to many on the E2 side, 0 to 1 on the E1 side means that E2 entity can participate in at most one relationship set and even entity can participate in many relationships set. So one is many, one is one. In other words, the relationship is many to 1 from E2 to the E1. And these values such as 1 or asterisk may be written on edges with a single value 1 on edge is treated as the equivalent to 1 is to 1, while asterisk is equivalent to 0 asterisk. And this also supports the generalization, and the notation is basically the same as in ER notation that includes a representation of the disjoint and overlapping generalization that do not correspond to the ER notation that I have seen. For example, a line between two entity sets with a small diamond at one end specifies that the entity in the diamond side contains other entity. That is aggregation in the UML terminology. They do not confuse with the aggregation in the ER model. For example, when I talk about the vehicle entity, that may contains an engine entity also. And UML class diagrams also provides notation to represent object-oriented language features such as the interface. So this also represents the interfaces with the help of UML diagrams, with the help of the UML class diagrams that represents the entities. Now, when we talk about the other aspects of database design, that also includes with the extensive discussion of the schema design that may be used with the schema component. That is also a part of the component design, database design. And there are indeed several other considerations that we address more fully in subsequent chapters that is used in the data constraint that is used with the relational database design. So we have seen a variety of the data constraint that can be expressed using the SQL, including primary key constraint, foreign key constraint, check constraint, assertions, and triggers. So these constraints serve several purposes, and the most obvious one is the automation of the consistency preservation. And by expressing the constraints in the SQL data definition language, the designer is able to ensure that the database system itself enforces the constraints, whatever the constraint that enforce, that whatever the database system that it is used that enforces a constraint. And this is more reliable than relying on each application program individually to enforce constraints. And it also provides a central location for the updation of the constraints and the addition of the new ones. And the further advantage of stating constraint is that constraints are particularly useful in designing relational database schemas. And if we know a particular, for example, a social security number, that is the SSN, uniquely identifies a person, that we can use a person's security or social security number, that is the SSN, to link the data related to that person. In India, that is captured by using the Aadhaar number. Yes, but over there it is using the SSN number. So that is basically a unique number that identifies a person, that we can use a person's social security number to link the data related to that person, even if these data appears in multiple relations. And with contrast with that, for example, eye color, which is not a unique identifier, because eye color is same for each and every one person, that is black or the grayish, that depends, that cannot be used to link the data pertaining to a specific person across the relations, because that person data could not be differentiated from data pertaining to other people with the same eye color. And in this, we generated a set of the relation schema for a given ER diagrams using the constraints that is specified in the design. That formalizes the idea and the related one and shows how they can assist in the design of a relational database schemas. And the formal approach that is used in the relation database schema is to use with the allows us to state in a precise manner when a given design or when a given design is a good one to ensure or to transform the poor designs, whatever the poor designs, into a better ones. And we shall see that the process of starting with an entity relationship diagrams, that ER designs, and generating the relation schema algorithmically from that design, that provides a good start to the design process. And data constraints are useful as well in determining the physical structure of the data. And it may be useful to store data that are closely related with each other in physical proximity on the disk so as to gain the efficiencies in a disk access. And certain index structures works better when an index is on the primary key. So when the index is on the primary key, so there are multiple procedures, there are multiple access that is defined on the key success. And constraints enforcement comes at the potentially higher risk in performance check each time the database is updated. So whenever a database is updated, it is checking with a high update with a high price. And for each update, the system must check each and every constraints and each and every part. And system must check all of the constraints and either reject update that fails, that do not define that constraint or execute appropriate triggers. And the significance of the performance penalty depends only on the performance of the update, but also on how the database is designed, how it is used. And indeed of the efficiency of the testing of a certain types of constraint, that is an important aspect of the discussion of the relation diagrams or database schemas. The next one is the users requirement, queries, and the performance. So this is the critical aspects of most enterprise information systems. That also pertains not only to the efficient use of computing and storage hardware being used, but also the efficiency of the people who interact with the system and the processes that depends upon database system or database data. And there are two main metrics for performance. One is the throughput, one is the response time. Throughput means the number of queries of the update, also referred as a transaction that can be processed on an average per unit of the time. That is a throughput. Response time, that is the amount of time a single transaction can take from start to finish. That is from starting point to the finish point, how much time it taking out in either the average case or the worst case. That is the response time. And system that can process large number of transactions in a batch style focus on having high throughput, and system must interact with the people or time critical system that often also focus on the response time. And these two metrics are not equivalent, that are not used with each other, and high throughput also arises from obtaining high utilization of the system components. So this also requires a SQL where clause. Now the next part is the types of the queries that we discussed already. For example, one of the clause that is used to check the condition is where clause, that are more likely to happen or the appears, that are expected to be the most frequently helpful in the process design and the design process. And the queries that involves joins requires more resources to evaluate than those that do not have. And in cases where a join is required, the database admin may also choose to create an index that facilitates an evaluation of that join. And for such queries, whether a join is involved or not, indices can be created to speed the evaluation, to take the evaluation of the selection predicates that are likely to happen with the aspects of the queries that affects the choices of indices and is the relative mix of the update and the read operation. And while an index may also speed the queries, it also shows the updates which are forced to do extra income or extra work to maintain the accuracy of the index. The next one is the authorization requirements. This authorization constraints also affect the design of the database as well, because SQL also allows the access to be granted to users on the basis of components of the logical design of the database, whatever the logical design it is using now. So this logical design may also need to be decomposed into two or more schemas to facilitate the granting of the access rights in SQL programming. That is the structured query language, in which it facilitates what are the job functions, job roles, medical benefits, employee record, yes, with the privileges that may be a read, write, execute, that can be decomposed, that can be broken out into the two or more schemas, with the access rights, with decomposition, with users that needs to be used with the payroll data while being denied to the job data.